Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over part 1 of our fraction review series, and the focus will be on simplifying fractions involving two operations. Alright, so the instructions are for us to evaluate the given expressions. Okay. Now let's take a look at question number 1. What if we were to evaluate the expression 5 over 6 minus 1 and 1/6 minus 1 over 2? Now, following the order of operations, which fractions do we want to evaluate first? Which pair of fractions? So let's take a look at our order of operations real quick. Please excuse my dear Aunt Sally. So we have parentheses, you simplify whatever is in the parentheses, and then you have the exponents, you then multiply and divide from left to right, and then you add and subtract from left to right. 1 and 1/6 minus 1 over 2 is grouped together in the parentheses, so that has a higher priority. Okay, so let's evaluate that first, and then we'll subtract it from 5/6. Okay, so whenever you're subtracting fractions, you want to express them as improper fractions whenever you have mixed numbers. Okay, so 1 and 1/6, we need to convert that to an improper fraction. We just multiply 6 times 1, and we add the result to 1 over 6. So that gives us 5 over 6 minus 6 times 1 is 6 plus 1 is 7. 7 over 6 minus 1 over 2. Now, how do we subtract fractions? In order to subtract fractions, the denominators have to be the same. They have to be equal to the LCD. So what is the LCD of 6 and 2? What is the smallest number that 6 and 2 can go into evenly? The smallest number that 6 and 2 can go into evenly is 6. Okay, if you notice, 2 is a multiple. 2 goes into 6. 6 is a multiple of 2. So whenever you have a string of numbers and every other number is a factor of one of the numbers, namely the biggest, then that is automatically the LCD. Okay? Alright, so let's go ahead and express these two as equivalent fractions with a denominator of 6. This already has 6 as a denominator. This 1/2 needs to be altered, so we need to multiply it by whatever integer results in a value of 6 in the denominator. Okay, so we just multiply by 3. That will accomplish the goal. So we have 5 over 6 minus 7/6 minus 3 over 6. Now let's simplify that further. We have 5 over 6. The rule for subtracting fractions is that you add or subtract the numerator, keeping the denominator the same. We're subtracting here, so we just subtract the numerator. 7 minus 3 is 4, keeping the denominator the same. Okay, so we have 5 over 6 minus, the coefficient here is 1. It's invisible, so you just distribute the 1 there. So you have 4 over 6. 5 over 6 minus 4 over 6. This is nice because the denominators are already the same. So we will just simply subtract the numerator and keep the denominator the same. Our answer is 1 over 6. Now let's take a look at question number 2. What if we have 2 and 2/5 multiplied by 1 and 5/6 divided by 2 5 over 6? Now here we also want to express the numbers as improper fractions since we have mixed numbers here. Let's start with 2 and 2/5, following the same procedure we talked about earlier. We multiply 5 times 2, which is 10 plus 2, 12 over 5, times 6 times 1, which is 6 plus 5, that's 11 over 6, divided by convert this to improper fractions also. 6 times 2 is 12 plus 5 is 17 over 6. Now, following our order of operations, we have parentheses here, so we are going to do that first, and then we will divide. Now, when you're multiplying fractions, you can multiply and reduce, or you can cross-reduce, then multiply. The optimal strategy will be to cross-reduce and then multiply, because you will be dealing with the product of small numbers if there are common factors that can be cancelled out. So let's look at the numerator and denominators, either vertically or diagonally. Are there any common factors that can be divided out from a numerator and the corresponding denominator? The answer is yes. Take a look at this diagonal right here. The 6 and 12 have a greatest common factor of 6. So 6 divided by 6 is 1, and 6 divided by 12 is 2. No other simplification can be done. 5 and 2 don't have any common factors, neither does 5 and 11. So we are now going to multiply. Okay? When you're multiplying fractions, you multiply the numerator and the numerator. So we have 22 over the denominator, 5 times 1 times denominator, over 5. Now, when you're dividing fractions, I'll do that step next, okay? So divided by 17 over 6. Now, when you're dividing fractions, it's the same thing as multiplying by the reciprocal of the divisor, okay? So 22 divided by 5 divided by 17 over 6 is the same thing as 22 over 5. This is the dividend times the reciprocal of the divisor, 6 over 17. Okay, this procedure is commonly known as drop. You drop the dividend, change the division to a times, and then flip. Okay, so don't forget, whenever you're dividing fractions, you drop, change, flip. It's also a nice strategy for simplifying complex fractions involving division. Okay, all right, so we have this situation right here. Now all we're going to do is ask ourselves, are there any factors that we can reduce? Does 5 have any factors with 22 or 6? The answer is no. 17 doesn't go into any of these either. Neither do they have a common factor. These two denominator values are prime. Okay. Okay, so since nothing goes, we just simply multiply the numerator times numerator, divided by denominator times denominator. This is how you multiply fractions. Okay, 22 times 6 is 132. You just add 12 to 120. 17 times 5 is 50 plus 35, which is 85. Okay, so that's the answer to question number 2. All right, let's take a look at question 3. Let's say we have 3 and 3/4 times 2 and a half times 2 and 2/5. We have the product of 3 mixed numbers. So what we're going to do is express all of them as improper fraction. Multiply, add over the denominator, multiply, add, multiply, add. Okay, 4 times 3 is 12, plus 3 is 15 over 4, times 2 times 2 is 4, plus 1 is 5, 5 over 2, times 5 times 2 is 10, plus 2, which is 12, over 5. All right, now we have a product of 3 fractions. So we can ask ourselves, can we reduce in any way? Are there any common factors between any of the denominators and any numerator? And the answer is yes. 2 and 12 have a common factor of 2. 2 goes into 2 ones, 2 goes into 12, 6 times. Oh, take a look at the 5s here. 5 goes into itself once, 5 goes into 5 once. Are there any common factors that we can reduce before multiplying. If you notice, 6 and 4 are even numbers. All even numbers have a common factor of 2, okay? 2 or greater. So 4 and 6, in this case, the common factor is 2. So you divide 4 by 2, you get 2. And you divide 6 by 2, you get 3. Alright, so now we're just going to multiply across. Numerators times each other. So we have 15 times 1 times 3. Okay, divided by the denominators multiplied by each other. Our final result is 15 times 3, which is 45, divided by 2 times 1 times 1, which is 2. 45 over 2 is the answer to question number 3. Alright, let's take a look at question 4. Now, what if we have 3, an integer, minus 1 and 1/6, minus 3 over 2? So we have an integer, a mixed number, and an improper fraction. So how can we work with scenarios like this? So what you want to do is express all of them as fractions, either proper fractions or improper fractions, depending on what you have. Okay? How do we express 3, an integer, as a fraction? We can express it as an improper fraction. All we just do is put it as 3 divided by 1. Okay? 1 and 1/6, multiply and add. You have 7 over 6 minus, this is already in the desired form, so we'll leave it alone. Alright, now let's see. To combine these, we need to have identical denominators. Okay, so what we need to find is the LCD of the denominators. What is the LCD of 1, 6, and 2? The smallest number that can go into all these three numbers here, or that all these three numbers can go into. So the smallest number that all these three numbers can divide evenly, the lowest common divisor, is 6. Notice 2 goes into 6 and 1 goes into 6, so 6 is automatically the LCD since 6 goes into itself. Alright, the goal is to express all these fractions as equivalent fractions with the denominator of 6. So to accomplish that, 3 over 1 we have to multiply by 6. In the numerator and denominator, 7 over 6 has the desired denominator already. 3 over 2 you just multiply by 3 top and bottom. Now let's simplify. 3 times 6 is 18 over 6 minus 7 over 6 minus 9 over 6. Now we have equivalent fractions with the denominator equal to 6, which is excellent. Now, following the order of operations, we have two subtractions here. We just go from left to right, okay? So we can start from the first two fractions, 18 over 6 minus 7 over 6. You subtract the numerators, 11, keep the denominators the same, 6, minus 9 over 6. Now we can simply subtract the numerators, 11 minus 9 is 2, over, keep the denominator the same. Okay? Can we reduce this? Is there an integer other than 1 that goes into these two numbers? The answer is yes. We can reduce by 2. So divide the numerator and denominator by 2. And that gives us a final result of 1 over 3. So there goes the answer for question number 4. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your review of fractions, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments about the contents of this presentation, just place your questions or comments in the comments section below, and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to the remainder of this fractions review series. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.